everyone, and welcome to our last unit, Unit 5, Part 2. Today's lesson will start with Lesson 33.1. Our notes are going to come from the supplemental note sheet that is either linked in the Google Classroom or you can take notes in a notebook as well. You'll want a pencil to work through this with. Now on this note sheet, we're going to start with kind of a little warm-up. So what are 4 real-life 4-dimensional objects, and what is the 3D shape that it looks like? So try to name 4 if you can. Well, some examples that you might have found were maybe a Kleenex box, which we would call a prism. As an example, obviously some kind of ball, particularly we'll say a baseball, that would be a sphere. Maybe you said a can of soup, which would be a cylinder. And finally, I came up with a funnel. So if you're trying to use a funnel, that's kind of like a cone with an open top. Now, moving on to talking a little specifically about 3-dimensional figures, we have polyhedra, or one singular polyhedron, and we have figures that are not polyhedra. What is the difference between our 3D shapes that are polyhedra versus the ones that are not polyhedra? Well, possibly you noticed with the polyhedra that these ones are dealing with faces that are polygons, kind of bringing it back to what we were talking about in the first part of Unit 5, Part 1, and basically we're saying that there are no circles involved, right? There are polygons, starting kind of with the triangle and going up to an infinite amount of gons, versus our not polyhedra, which has a circular. Now, looking at, again, A, B, C, D, E, and F, which of these would be considered prisms versus pyramids? Well, our prisms are going to be figures A and B. Those are 2 different types of prisms, but we see these would be examples of prisms versus C, which would be an example of a pyramid. We'll talk more about naming those later on. Now, in a prism, all of our faces are going to be polygons. And we know that the edge is where the line segment intersects the different faces. So, for instance, we see up here on our prisms, this would be an example of an edge. It's where our faces are meeting up. And again, those are segments. A prism has 2 congruent faces that are called the bases, right? And those are different polygons, while a pyramid will only have 1 base. A pyramid has all faces that intersect at a point called the vertex. Okay, so we see this up in our pyramid. They're intersecting up here at the tippy top. That is our vertex. And when we have a prism, all of the lateral faces are going to be parallelograms. Specifically, they can be rectangles or squares. We say parallelogram to kind of be the over-encompassing, or you could say rectangles specifically. And in a pyramid, all the lateral faces are. If we kind of look at the difference between those, kind of all the way around, we see here for our lateral faces, obviously not the pentagonal base, but we have these rectangular faces all around, versus with our pyramid, these faces are all triangular, while the base is a pentagon. Last but not least, in a rectangular prism, the bases are going to be any regular. So this is going to really vary. They can be squares, they can be rectangles, you might see pentagons like up above, hexagons, octagons, you get the idea, etc., basically. Now, from here, we get into identifying. So notice we have here in this first one, we have a prism, And the bases are going to be in this one, they are specifically right triangles. So we'd call this our base shape here is a triangle. So specifically with this prism, what we would call this is a triangular prism. Now, the second one, because again it has two bases, is also going to be a prism, but note because of two bases. But notice this particular shape is going to be a pentagon. So we would instead call this a pentagonal prism. So the base helps us name our prisms. Okay. Now the next one is an example of a pyramid because we only have this one base. And notice with the tick marks, what that is telling us is that these are all the same size sides. So we would call this a square. What's going on here? So we would call this a square pyramid based on the shape of our base. And finally, we have another prism because again, we have two bases here. And the bases this time are just rectangles because they're not congruent. We can't say that they're all sides are congruent. So we can't call it a square. We'll just call it a rectangle. So this would be specifically a rectangular prism. Okay, so in your own words, what is the difference between a pyramid and a prism? Hopefully you notice that the biggest difference between our pyramids and our prisms is that the pyramids have one base and all their faces that are lateral are triangles, while our prisms have two bases and all their lateral faces are rectangles. Now, the next piece throughout here is talking about a specific vocab word that we call a cross section. And a cross section of the solid is if we sliced into a solid, what shape is being made. So notice here in this first example, when they sliced into this, we have a cross section that looks like either a square or a rectangle. Here, when they slid into this, we have a circular shape being formed. And then here we kind of have two different ones. This first one, when they cut into it, it was a rectangle versus when they cut the other direction, it was a circle. Okay, so think about like if it's a magician in a show and it's cutting through a box, kind of what shape are you creating when you make that cut? So we see here some examples, and I'll link this for you guys to play around with as well. Specifically when we kind of cut either horizontally or vertically when we're going straight up and down. We can kind of notice specifically with the vertical and the horizontal slices, some different shapes, two-dimensional shapes being formed. And that's what's nice here. We see the shape that we kind of are getting through that. So if we specifically focus on a prism, and again, we can kind of change the size of this from a triangle or even a rectangular prism, and then moving these either vertically or horizontally being cut, the different shapes that are being cut. So if we go back here, just looking at different ways that they are cutting into these prisms, this first one, if you were cutting horizontally, we see that this shape is being created is a square or a rectangle. In particular, in this one, it's going to be a rectangle because it wasn't kind of equalized. So you're going to kind of use your imagination on this one. They don't show up very well, but this one is going to have a rectangular shape. Versus B, when we're cutting through, again, it's hard to kind of see, but kind of sketch in to visualize. And notice they have the 4 congruent markings. This one's more specifically a square when you cut into it. And then last but not least, if we kind of look at this horizontally, and this might be a nice one to look at on our figure here, if we cut kind of diagonally we see these shapes being formed again as kind of the rectangular shape. Okay, so we kind of stay there. Now, for the most part, we focus on with these. We like to focus on either being straight up and down, so that would be vertical like this, or horizontally, which we look kind of sideways like that. So now looking at these, then we have, if we were going to cut a prism parallel to the base, what would it be? Well, again, if we go back to this example, and let's say we have a different size base. Let's say we have a hexagonal prism. If we slice parallel to the base, okay, so parallel to the base is the same direction. If we slice into it this way, notice no matter where we are slicing this on here, it's that same exact shape as the base. It's a hexagon. So when you, and then it would be if we make this an octagon or a nonagon or a rectangle or a triangle, it's that same shape as the base, no matter what we're doing. So whenever it is parallel to the base for a prism, the cross section is always going to be congruent to the base. Okay, it's going to be the exact same shape, exact same size. Okay, so it's the same shape as the base. Versus when something is perpendicular, and we have a perpendicular to the base, that's when we're flipping this around. So if we're going perpendicular, we're going up and down, and that's not the same direction as the base. Notice on this one, no matter where we slice it, this is consistently a rectangle. Okay, this is consistently some sort of rectangle, either a square or a rectangle, depending, and we can kind of rotate this around, still perpendicular to the base, and we see it's still a rectangular shape. So we would say that no matter what, and this is going to go for all of our, whether it's got, 5 sides, 6 sides, notice no matter how many sides we're making it, it's always that rectangular shape when it's perpendicular. So we would say on this one that it is going to always be a rectangle, no matter what. Now, when we talk about a pyramid, specifically this one's asking about a hexagonal pyramid, so that's going to look like this. If we slice in this one, it's going to kind of depend on where you're at, but notice you're creating almost like a trapezoidal type figure when we are doing this. Notice it kind of looks like a trapezoid as we move it around sometimes. Through this. So that's when we're cutting perpendicular, not through the vertex. Now, if we're directly through that tippy top vertex, what we're noticing is it's always looking like a triangle. So any of these that are trapezoid shape, these are going to be when we are perpendicular to the base, but not through the vertex. Versus the ones that are triangular shape are going to be perpendicular to the base, but specifically through the vertex. Versus these ones that are hexagonal shaped will have to be the same shape as the base. So these would be an example of when we are parallel to the base, because if they look like a hexagon, they have to be the same. Now, as we move this slide up and down, notice it's not going to be the exact same size, but it's always going to be a hexagon. Okay, so the ones that look like hexagons would have to be the ones that are parallel to the base. Last but not least, we want to talk about the cross sections again. So if we have cross sections that are parallel to the base, remember those are the same direction as our base, aka the same shape as our base when we're slicing them. So on this first one, the cross section when it's parallel would be a triangle. On this one, when we are parallel to the base, it would be a rectangle. And last but not least on this one, again, same shape. This one would have to be a pentagon. Versus when we are perpendicular to the base, remember from up above, if we were talking about prisms, it would always be a rectangle. Here with pyramids, again, it's going to be dependent upon, are you through the vertex? In this case, you are through the vertex. So remember, when you're through the vertex, that's when it's going to be a triangle. And that's going to actually be for both of these. Had it not been through the vertex, it would have been a trapezoid. And again, we talked about that up here being through the vertex versus not through the vertex. Okay. All right. Thanks everyone for watching. I'm going to work more with these in class.